There we go.
Morning, everybody. Welcome to the Maker in the Mix podcast. It is April 26th, Wednesday, 8 a.m. So today we kind of wanted to address the topic of kind of cracking in general. I think we're going to zoom in on one or two different types of cracking that we've, had experience with or whatever, and why those things happen. So, I wanted to just quickly list off the types of cracking and then kind of what we're going to zoom in on. So shrinkage, settling, premature drying, thermal, heaving, which would be like a root or something coming up from underneath, and flexural cracking. So the ones that kind of matter to us are going to certainly be shrinkage, premature drying, thermal, and flexural. So I think, from a description, they're pretty self-descripting descriptors. So, shrinkage cracking, obviously it's shrinking. And, for us, that tends to appear in, if we're doing a non-structural face coat, shrinkage cracking would appear for us in the face coat because it's not reinforced often. Premature drying can happen for a number of reasons, failing to cover your concrete. I think a lack of a curing polymer could potentially be a possibility. There's a number of reasons why premature drying could happen. Thermal cracking, heat. A lot of us are using rapid set. I've had thermal cracking from, letting it get too hot, so not using a retarder and kind of pulling that heat curve down, and then certainly flexural cracking, which we've all probably dealt with in some form or fashion. So that's a broad, brief 30,000 foot overview of kind of what we're going to be talking about today. I do think we'll probably end up zooming in on map cracking, which is a function of premature drying for the most part. So Jeff, I'll let you take it from there, but that's kind of the introduction. Welcome to everybody who is already on and anybody who will join and watch later. So
fantastic. So as Caleb mentioned, there's a bunch of different kinds of
background noise.
And when you look at your concrete, like when we're making something for a customer, whether it's a piece of furniture or a countertop or wall panel or whatever, right? We can't tolerate cracks. And it's not that we can't tolerate them. Our customers generally don't tolerate cracks. They see anything that looks like a crack, no matter what it is, as a flaw. And the hard reality that we face is we've set the bar for the aesthetics of our product so high, compared to other kinds of concrete in the world. There's no room in general. Like there are specific examples where you want cracks in the concrete because that's part of the aesthetic design that you've created. But by and large, our customers will not tolerate a crack in our concrete, in their concrete. It's not our concrete, it's their concrete. And there's really no way to fix that. There are certain special circumstances if you're really clever or have spent a lot of time trying to figure that out, how to make a crack disappear. But the general state of things is if you got a crack, the only way to fix it is to redo it. And that's a harsh reality. So the moral of this whole topic is how do cracks happen and really how to prevent them, because there's no real fix. You can't rub a cement paste into a crack and hope that it goes away. It's not like a TV DIY fix where you see the quick 5-second little thing, because that crack is still there. You've just filled it in. It's not glue.
Well, and one thing, that I think some of us could embrace, right, is there can be beauty in imperfection. So I would say too that while we as a general rule can't tolerate cracks, there are aesthetic ways to, the Japanese art of kintsugi comes to mind, mending things with gold, or a gold resin or whatever. So I do think that there is room in the artistic world for doing something like that intentionally. What we're really going to be zeroing in on is unintentional cracking. And
That's a good point, because like I know some of our colleagues, Caleb, part of their aesthetic is actually intentionally creating a cracked face coat.
yeah. I mean, I did it in my own kitchen.
Yeah.
On purpose,
And
and ground it with a different color, and it's awesome.
just like a crackle glaze on ceramic, that's a specific look.
Yeah,
But we're talking about things that are unexpected.
absolutely.
So we're going to ultimately head to and focus in on map cracking, or some people call it crazing. But I want to step through some of the other cracks types first to kind of get them out of the way. So, we generally don't worry about things like frost heave cracking our sidewalks, because we're not making sidewalk. But if you do a quick internet search on map cracking or what causes crazing or things like that, you'll generate a bunch of different articles written by a lot of different organizations, ACI, the American Concrete Institute, Concrete Contractor Magazine, a bunch of other places that summarize things, and they focus largely and logically on what I consider regular concrete: sidewalks, floor slabs, walls, that sort of thing, construction grade concrete. And what we do as artisans, as makers, as producers, tends to be a little bit more esoteric, a little bit more refined. And our mix designs tend to be a little more complex and oftentimes quite different from conventional concrete. So some of the things you're going to read about in an article about, like, well, you have to worry about bleed water and this and that, like, by and large, we don't deal with that, because our concrete mixes don't have that kind of water. We don't deal with that. And it's a non-issue. Just like we don't have to worry about frost heave cracking or a root growing under our countertop. I mean, it's possible. I've had a house break my concrete, and I think we have an article on the CCI website about that, where I did a kitchen in a house where they added onto the kitchen, and the kitchen was added onto land that was filled in. They had extended the backyard and built it up, but they didn't do a great job at compacting things, which is really important. And the house settled. And in the settling of the house, you could see the crack in the drywall, and then the crack through the countertop where the house broke the countertop. It wasn't a fault of the countertop. My concrete's job is not to hold your house together. So that's a fundamental flaw. That's a clear external source, right? So that's a very different kind of crack. Now, again, one of your
and I want to interject and define. A lot of us talk about hairline cracking. Defining that, I think something you've always told me, Jeff, is that a hairline crack can be defined as if you cannot stick a piece of paper into it.
That's one of the
hairline crack. That and smaller. Now, aesthetically, for us, unless that's intentional, even something like that is unacceptable. Absolutely. I mean, you can sometimes get away with map cracking because sometimes the sealer won't show it, but sometimes it will. And so that's why I think, I know that I have, gone through various iterations of my business where I've used different mix designs, or I've used different ingredients, or I've used different curing processes, or whatever the case may be. And I have, I've had experiences with map cracking over the years. I'm not having those issues right now. I think I'm using good practices, and that's great. But, I think it's good to draw on the experiences that we've had. And so, that's definitely, I've had experiences where, certain color, let's say it's in a dark color. Well, unfortunately, they're going to get darker with sealer. And so you're going to see that crazing. With white, you're less likely to see it. Right. And so, maybe you have been for the last 6 months doing largely white concrete and you don't see them, but maybe you just did a gray or a black piece and you're like, oh crap, now I see it. And maybe it's been happening for 6 months. And so I think it's worth, really paying attention to, if you notice it today or tomorrow or in a month, look at what you've been doing and see if anything's changed over the,
we'll dive more into that when we actually get to map cracking. But talking about hairline cracks and how you define it, that's largely up to you to define it. There isn't an industry standard as far as I'm concerned about what again, construction grade concrete is
assuming it's
very-
not structural, because
Right.
that's important as well.
Yeah, right. And usually hairline cracks occur for a variety of different reasons. And again, it's who's creating that definition. And this is going to, excuse me, be a topic for a future podcast, is setting expectations.
Oh, sure.
Incredibly important. So this is one of those subsets of setting expectations, is what can you expect from your concrete? What, as a customer, what can you expect to happen when it's delivered, when you live with it, and over time? Because concrete is not a static material that never changes.
Right.
It undergoes changes internally, and it undergoes external changes because of its environment. And we can get into that a little bit later. But again, getting back to the basics of cracking, all cracks, no matter what they are, flexural cracks, hairline cracks, heaving cracks, whatever, are even plastic shrinkage cracks, are tension failures. This is where the concrete itself is being pulled apart and it can't hold itself together. So
right, because ultimately, with or without reinforcement, concrete is still a hard and brittle material. So even if you've got, I mean, like GFRC has wildly more flexural strength than conventional concrete, but still, if you bend it, it will crack.
Correct. So
stress it, I should say.
You stress it, yeah. When concrete, every material in the universe has some stretchiness to it. Rubber is very, very stretchy. Carbon, like carbon fiber, is very, very stiff, very non-stretchy, but it's still stretchy to a little bit, and that's called modulus. Every material has a degree of stretchiness, even concrete. It's very, very small. And when you exceed that, when you stretch it too much, it fails. It fails brittly, as you just mentioned. And we all know that. And the job of reinforcement, whether it's fibers or rebar, is not...
It's to take the load off the concrete.
It's to take the load off the concrete, but even more so, you're putting something stiffer and less stretchy in the concrete, and enough of it to stop the concrete from stretching to the point where it won't crack. It's still within its called elastic limit. It's still within its stretchy range, which is tiny, 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 very small amount. So if you exceed that, you get a crack.
Right.
And now all the different kinds of concretes that happen, all the different cracks that happen for different reasons. Of course, we're leaning toward, map cracking, which is all superficial, and it all happens at a certain time and generally for certain reasons. But there are other manifestations of that. Let's talk about, flexural crack, bending cracking. You've got a big long slab. What's the biggest piece you've made recently? Like
recently, I did a 21-foot hearth about a year ago. So
a long 21-foot hearth, very easy to bend, right? You pick it up at the wrong end, it's wobbly, it's floppy, right? You bend it enough. When you bend something, you're stretching it. When you're stretching it, you're creating a lot of tension on that side that's stretching more. And if you bend it too much, you get a crack. You get flexural cracks. And flexural cracks tend to occur, like if this is the beam, they run perpendicular to the scope of bending. So they're going to run this way. So if you see a whole bunch of lines all together in kind of parallel, especially toward the middle, those tend to be flexural cracks. If you see one deep crack that runs all the way across and down the face,
that would be a brittle failure.
That's a brittle failure. That's a very deep, that's a structural failure right there.
Yep. Mm-hmm.
Hairline cracks, flexural cracks can show up. Hairline cracks are merely a description of the size of the crack, right? Again, my personal definition for my customers, because it's easy, because most customers have a piece of copy paper. It's like, if you can't get the piece of copy paper in the crack, I'm calling that a hairline crack. Mm-hmm. That's just my definition. That's part of me setting those expectations to the customer. It's just an easy rule of thumb, because who's going to have, I have one, and maybe you have one, because if you work on cars, maybe you do, or
Oh, feeler gauge.
you got a feeler gauge. You got a 1,000th of an inch, which would be what?
But even still, I mean, to my eyes, if I've got something I can fit anything into, I've got a problem.
If you can see it, you know, that's the more critical stages. If you can see it,
Right.
it's there, it's real. And if it's there and they don't
And to your point of it's there, it's real. If you can't see it, it isn't real.
Exactly.
Because everything is what it looks like.
And a long time ago, I did a demonstration. This was, I think, 2003. This is pre-GFRC days. And this is kind of when PVA fibers were starting to come on the market. And I made an 8-foot long, basically an 8-foot 2x6. So it was 8 foot long, 1.5 inch thick, 6-inch wide beam. And there might be pictures on the CCI website and an article about it. Steel reinforced, by the way, had to be. Supported at each end, and I had 500 pounds of sand on it. Impressive on itself. And I had the president of ACI standing on it with me at a conference. And so that was pretty cool. The thing is, there were no visible cracks in it. Now, were there cracks in it? Absolutely. There were thousands of them. And that was the function of the PVA fibers, not to hold the beam together, because they can't do that. Their job was to distribute the cracks, so you didn't have one giant big crack that was obvious. You had thousands of microscopic cracks that you couldn't see.
Which I was talking to you, Jeff, the other day, and we were talking about ECC as what's it stand for? Engineered
Cementitious composite.
Cementitious composite. That's right.
Yeah.
So you know, you were telling me that the origins of that are pretty fascinating, but it's a seismic material, so it is intended to, in a seismic event, in a structural event, crack and fail, but the idea is it will hold itself together long enough to keep people safe and get people out of the building. So to that point on the countertop perspective, like, it's the PVA's job are to
distribute
the cracking so that you don't, you know,
spread it out.
So it fail brittly, but also in our niche industry, it's so that you don't see them.
Right. And if a client can't see a crack, it's not
there.
It's, and that's really the moral of that story. So you could argue very reasonably that incorporating those kinds of fibers into your face mixes might be a way to control cracking, flex cracking, or other kinds of cracking if you have them. If you have
something like that, is not, I don't think should be used as a structural fiber, and we can get into that debate.
That's another topic.
But I know some guys are using these little HD fibers, little tiny glass fibers, that apparently don't show up. I've never used them, but I've heard good.
I have them. They're 3 millimeter long, 18 micron. I think I could be wrong. Glass fibers. They're air glass fibers, and the fantastic thing about them is they're absolutely invisible. They're not.
It's cramped.
Yeah. So when you machine them, you know, if you hone your concrete and do a salt and pepper finish, you physically cannot see them, nor can you feel them. And a 0.5% dose in a mist coat sprays beautifully. So I'm just putting that out there. They're a great way to do that kind of control, but I think it's more of if you need that, right?
Well, and so really we should kind of move into the subject of this situation, which is map cracking specifically.
So what is map cracking? And it's basically the surface skin of your concrete. And it's usually, it only extends about 1/8 of an inch deep, 3 millimeters. That's, you know, you're gonna read that. That's a number that's out there on the internet. I've never taken a tile saw and cut through one and actually measured it, but experience have said it's shallow. They're shallow superficial cracks, and they tend to happen very quickly after casting. So within a few days, I've even personally seen it happen within a few hours.
Sure.
And they typically manifest themselves as a random crackle of interconnected cracks that form like little rough random geometric shapes that are all connected. So it's not like a linear flex crack, which is pretty easy to identify as a flex crack. Map crack is just kind of random everywhere. It might start.
I mean, I think it gets. I mean, I don't know that this is the case, but it could be getting the map name from what it looks like.
Yeah, it looks like a map. Yeah. I've even heard the term spider cracks, so it's like a spider web. And the main cause of that in most concrete situations is poor curing conditions. Basically, you're taking your concrete out and it's drying too fast. It's in an environment that's too dry, and the surface of your concrete is drying out and shrinking. And it's shrinking and can't withstand the shrinkage forces. So what, cracks are caused by tension. What's causing the tension? So when water evaporates, that movement of water creates a lot of capillary suction forces, which can be quite strong. That's how, water can go up trees and, can go up hundreds of feet into a tree. It's drawn up by capillary action through the tree and the respiration. That it's more than just that, but capillary action on its own is quite powerful. And if you've ever washed dishes and used a sponge and you're done washing the dishes that night, you squeeze out the sponge, you put the damp sponge on the countertop. In the morning when you come in and look at it, it's all curled and dried because the top surface that's exposed to the open air has dried more than the underside that's touching the countertop.
Oh, sure. Yeah.
Water evaporating has caused the sponge structure, which is not very strong, to shrink, to collapse. Right. And that's the driving force of curling, which on its own is another topic. But it's that drying action that is so harmful. And that's what causes the tension that creates the map cracking.
Yeah. So we've defined it.
How do you stop it?
How do you stop it? And what kind of, like, for our particular industry, what types of practices are causing that? And then certainly how do you stop it would be along those same.
My first state is if you have a mix design that allows moisture to leave the concrete rapidly, that's a problem. So that's the first thing, is change that. There's two easy ways to change that. One is less desirable than the other. One is to use a proper curing polymer. We've mentioned this in the past, and that's the function of a curing polymer. GFRC, the entire commercial industry that's been in use globally for the last 50 years, is incredibly dependent on curing polymers for everything to work, to be economically feasible. Because if you didn't use a curing polymer, you had better be wet curing your concrete long enough so that the structure of that concrete, especially the surface, can withstand the drying suction forces that create map cracking. Because if you don't, you get map cracking. So map cracks are a symptom of something that's not being done right. Either there's an ingredient that should be in your concrete that's not, because you're choosing to do certain curing situations, or you're not curing the concrete properly. And that means
now I'll add one thing to that is I have seen over the years that I've determined that there is an ingredient in whatever mix design I'm using that is causing something, even though there is a curing polymer. So I don't know what it is.
And that's another possibility. That's another aspect of it. And I've witnessed it and gone from elation of seeing this 4-meter long, beautiful piece of concrete I just made to after a few hours going, well, it's going in the dumpster, because you can visibly see cracks happen on the surface, and it's not from drying.
And I don't know the answer to that one.
And that's a material and ingredient thing. There's incompatibilities with things, and I can only, knowing some of the other things that cause cracking in concrete, take educated guesses. They're not really guesses. They're my hypothesis on why that cracking happened. And we'll get to that. We'll get to that. But let's get back to the main causes of map cracking. Let's say you have a brand new piece of concrete, right? You're using this mix that you've used for years, and all of a sudden, this one piece, you take it out of the mold, and it looks great. And as you're doing whatever you're going to do to it over the course of the next few hours or couple days, you notice, wow, you get to the point where you're going to go clean the piece off, ready to seal it. Like cleaning the sealing is absolutely good practice. And all of a sudden you notice there's map cracks everywhere, and they only show up when it's wet. What happened? Well, sometimes it's hard to figure out what happened, but in this instance, in this case, it turns out that maybe you were not the one who did the casting. Maybe you had an employee do the casting. And it turns out from talking to them that they sprayed their mist coat, and then they got a phone call or something. And instead of getting on it right away and getting that backer on it right away, when it's just at the right consistency, it's still moist, it's still pliable, et cetera, that mist coat dried out and it actually underwent not necessarily plastic shrinkage cracking, but because it started to dry out and it's so thin, it created a lot of internal stresses that manifested themselves after the piece was demolded. I've been on consulting jobs in Nevada, in Oakland, California, in a very, very big, very well-respected company. And that was the reason why they were having these problems, is pieces were being sprayed and the mist coat was just being left open to the open air. And that's an easy fix. That's just, okay, you got to change how you do things. In the Nevada case, it was 6% humidity and the shop was 100 degrees. So you're basically putting concrete in an oven. And concrete, and this is something that I see, especially with folks who don't really know concrete that well. They're not in the concrete industry, and they say, oh, well, I got to wait for my concrete to dry, because everybody thinks, your experience with things that get hard, like paint or glue when you're a kid, is you wait for that to dry. Well, these are chemical reactions. You actually don't want it to dry. Water is the fuel. It's like the most important ingredient. And so it
reminds me of a time before I bought my company that I believe my predecessor tried to consult with you on a process that ended up being, just not a great idea to begin with, because he wanted to I think kiln cure it or something.
Yeah. Put it no. It's like no. Drying is bad for concrete. And that's kind of the root cause of map cracking is drying of some premature drying, right? And if you have your piece of concrete and it comes out of the mold, you demold it the next day. I don't care what mix you're using. When you demold it very early in its age, in its life, it is a lot weaker than it will be when it's fully cured. Now, those of us who use Rapid Set, where it gains strength, 28-day strength in 24 hours for real, its chemistry happens so fast that it's unusual to see map cracking from drying, but you can get map cracking from thermal issues where it's thermally drying itself.
It's so hot.
It's so hot, you'll burn yourself if you touch it. It's basically drying itself out. So that's accelerated drying. It's accelerated curing, but it's also accelerated drying. We're talking regular concrete here, our regular concrete. But the point is still valid, is that keeping that concrete moist, and the important thing is to keep it continuously moist, not intermittently. You don't just slosh water on it in the morning and then come back in the afternoon. That's actually bad, and there are lots of articles written about that, how that actually can exacerbate things. But when I say it, keep it moist, that means keeping the internal humidity levels, the moisture content within the concrete high enough so that A, you don't have those suction forces trying to collapse everything, and B, water is the fuel that makes it stronger. And you want that concrete strong enough so that it can dry out and still remain as a strong crack-free skeleton.
And so a lot of those methods would be, the dog's about to bark, Boone, please stop. There's a runner going by the shop and Boone just can't handle it. So there are a couple of ways you could do that. A, use curing polymer, and that will keep the moisture in the concrete. B, you could cover it in plastic and put a heat blanket and put a steam unit. You know, I mean, you could steam cure it. You could full on wet cure it. Seems to me the easiest and most economic and least path of least resistance to a quality material would be to use curing polymer.
That's the logical thing, because that's what the GFRC industry as a whole chose half a century ago as the better solution, because the
half a century ago, Jeff, isn't that, I mean, you know, are there technologies that could, you know, circumvent that need, or is that something that's just, you know, it's the best because, or it's, you know, still in use because it's the best?
Well, there is no such thing as the best that applies to everything.
Sure.
Anytime you're working with a material, whether it's wood, whether it's steel, whether it's concrete, whether it's plastic, it's always a balance. And this is really what engineering is. And a lot of people don't understand this. It's not finding the best. It's finding the best solution at the cost that is acceptable.
Sure.
Right? I can make, you know, titanium, carbon fiber, whatever paper clips, and they're going to be the best paper clip. But if they cost $100 a piece, 99.99% of the people will simply say, that's ridiculous. I don't need that.
Right.
Right. So it's always a balance. Now, is there some esoteric, exotic technology out there that can prevent all map cracking? I don't know. But is it so expensive that 99.999% of the concrete industry simply says it's not worth it? Because there's so many other things that are cheaper that do exactly the same thing.
Yeah, I think what I'm getting at is, you know, if there was a better option, the industry at large that we're kind of a subset of would be using it.
Absolutely.
And maybe there will be a better option, you know, but it's like, I look at things like, I'm an Apple guy, Jeff's an Android guy, and I would put it out there that Android tends to adopt certain technology earlier. And in certain applications, I mean, maybe Samsung's figured it out, but maybe HTC hasn't. And so in certain applications, those things are buggy up front. Whereas Apple is going to wait on it. And when they put their phone out, it's going to do exactly what they say it's going to do, no more, no less.
Yep.
And so I think that what I'm looking at this as is the Apple approach, right? I want to use something that is reliable now and will do exactly what it says, no more, no less. And when something else takes that place, totally happy to switch to it.
Yeah. And that's a really good perspective to apply to this situation is, and I want to again go back to the GFRC to really drive this point home. And I'm using the GFRC industry because, well, it's outside of us. It's in fact we're
a derivative of it in theory.
We are not just in theory, literally. I mean, I know that some of the people who used to be in the GFRC industry back pre-2006, 2007, and they left and came into our industry and brought a lot of this. I mean, Hiram Ball, who's, I don't have the textbook with me, he's one of the people who authored and a lot of the code written for the commercial GFRC industry. He's the one who taught me how to do this. And he taught a lot of people how to do this. And
this being GFRC.
And the GFRC industry as a whole, and I have a lot of technical papers on this going back to the 80s. And even before that, polymer made it possible, made it economically feasible. Again, going back to just because, you know, you could do something, but if it's cost too much to do, is it worth doing? So before the days of polymer existed, the way they had to make GFRC, and we're not talking about little planters and doodads that we make, not that we make doodads, but the stuff we make is tiny. You know, when you're dealing with a 2 or 3 story building panel and you're doing cladding for an entire building where you're maybe making several thousand square feet of panels a day, every day of the week, you got to cure those right. And so they have to be wet cured, continuously wet cured in a fully 95+% humidity environment for 7 continuous days. So imagine the size of the facility and the infrastructure it needed to keep these things really, really damp. That's expensive. That's really expensive. And it was so expensive, even in the 70s, that many people said, hey, this is a great idea, but it just costs too much to do.
Right. And with the advent of polymer, you know, now they can cast them, strip them, and throw them outside.
Yeah. Now you don't need that expensive facility. That expensive facility can make more product. And like you said, it can just be stored outside, and it's colloquially termed air curing. But the function of a curing polymer is to hold the moisture in. Right? That's its job. That's its only job, is to hold the moisture in.
It's kind of funny that we started on matte cracking, we ended up back on polymer, and I think that's
But
a
it's all
logical
related.
conclusion.
It's all related. Everything about concrete is related to every choice you make, every ingredient you put in it, everything you do before, during, and after casting.
Absolutely
Makes a difference. And again, this is kind of to drive home, when you make really good concrete that is well designed and well thought out, that has everything it needs in it and nothing it doesn't, you generally don't have any problems with it. Now,
and I used this analogy, you know, the Android analogy, and I used the vehicle analogy a couple of weeks ago, but I think it holds true. You know, there's nothing wrong with new technology. There's nothing wrong with changing. There's nothing wrong with being open-minded. I think those are all super valuable and you know, asset producing traits. But, you know, if you look at a company like Mercedes, great car, but they tend to have technology that's a bit ahead of its time, right? I mean, Mercedes-Benz had the whole auto cruise control 10, 15 years before anybody else did it. And there were issues. You know, there were issues of it, you know, veering off the road. There were issues of it not working properly or whatever, because the kinks hadn't been ironed out. And frankly, I think Mercedes knows that their customer base would rather have the new technology than have the perfected technology. And I think that's a totally fair thing to say.
right.
I think it's totally fair to say, listen, you're allowed to prefer new over proven. Totally fine. But know that that's what you're preferring.
And accept the choices of, wow, it's going to cost me a lot of money to fix that new piece of technology that other cars don't have yet. And
and now Honda has it. And
yeah.
you can bet
Well,
that if you buy a Honda that's got it, it's going to work. You know,
the GFRC industry wouldn't exist if somebody didn't say, hey, let's look at different polymers in the concrete and see what that does. Now, there are a lot of reasons why, and again, I'm straying away from the main issue.
But it all ties together.
But it all ties together is, you know, I have a dry curing polymer. There are a bunch of dry curing polymers on the market. Why do people look at dry curing polymers over the liquid commercial GFRC polymers that were used and that still are being used? Is A, when you ship them, you're not shipping water, and B, they can freeze and it doesn't hurt them. So it doesn't cost you as much to ship in the winter, and you can buy in bulk and they don't go bad and things like that. There's a lot of positive reasons, but that doesn't make them all the same. And just to come back to the topic at hand, I have personally seen map cracking happen, and you have too, Caleb, in concrete that has a curing polymer in it. And in a certain situation, you saw map cracking when you normally didn't. And there are other reasons.
No, I mean, I had a piece that I used 2 separate mix designs in. Just I was marbling something, and it doesn't really matter why. But there was you could tell there was map cracking in the sections of the marbling that had that one mix design, and there wasn't in the sections that didn't. So that was a really fascinating side by side. And it is kind of an aside, but you know, you're. But back to the other week, your mix doesn't matter.
it's relevant because it goes back to what I said. Sometimes a mix has something in it that,
And I don't know how to answer that question. I mean, you can make educated guesses, but unless you're looking at the ingredient list
yeah,
of
and
whatever blended mix
you know,
design.
when you are using a mix design that you didn't make,
Right.
you go to the grocery store, you buy a box of cake mix. You're trusting that the ingredients that are in the cake mix are all good for you and will help you make the best cake that you can.
Right.
Right. So there's a trust level there.
Sure.
So one of the, and this is also well known in the construction industry, in the concrete industry as a whole, is if you, and this has to do with super plasticizers, it's known that if you use very high doses of some super plasticizers, that can lead to map cracking. Now, I don't know if that's a direct cause, too much is a direct cause, or is an indirect cause, meaning a lot of super plasticizers, when you use a high dose, have retarding characteristics. Now, these are not super plasticizers that intentionally have retarding characteristics for
It's
use.
like super red is a retarder, but that's not
exactly. But if you use a lot of a super plasticizer because you really want to make that concrete really fluid, or you made a big batch of concrete and it's sitting there and it's kind of stiffening up over time and it's not as fluid as you'd like, so you keep dumping more super plasticizer in to loosen it back up. There's a point, and I don't know what the point is because it's dependent on the chemistry, it's dependent on the brand, et cetera, but there's a point where there's so much super plasticizer in there, it starts to have a retarding characteristic, meaning the strength gain is slowed down. And one of the causes of map cracking is the concrete is not strong enough to resist the shrinkage forces caused by drying. And if you're a retarder, if you have something that's slowing your strength gain down in your concrete, then you might be seeing map cracking because of that.
Sure.
So that's another possibility. Even it could happen, even if you do follow good curing practices where you keep your piece covered, you're using curing polymer, et cetera. So I don't want to point everything to one cause, but there is a very common cause, especially in the concrete world, that has to do with premature drying, and you're not using curing polymer. Now, most concrete doesn't use curing polymers because it's too expensive for ordinary concrete. We need it for a lot of good reasons. And
I think so, and I think that would be a good time, because it's 8:45 and I want to make sure that we're respecting people's time listening. But to answer any questions that might be in the peanut gallery, and wrap it up. But I think the bottom line is, I think the most concise way to say it is map cracking can most of the time be traced to premature drying, and there are ways to prevent that, which we've kind of gone over in this podcast.
Yeah, I think that's a great summary. Like, curing polymers are not going to stop flexural cracking. They're not going to stop thermal cracking. They will cause, or they will stop or minimize premature drying, because that's their function, is to slow drying. So to wrap this up, yeah, map cracking, mostly caused by early drying and excessive drying.
Absolutely. There's one gentleman in the chat. Do you have any questions, sir? Or
if you do, go ahead and unmute yourself.
Yeah. Oh, hang on, he's still muted.
Hang on, let me. Okay, I can only.
There should be a way to unmute yourself there in the audio section.
Yeah.
Oh, I think I heard something. No, he's still muted. I still see a red microphone next to his participant name.
Buddy had the same issue the other day when we talked. Yeah. if you can, on the very left side of your screen, there should be a little microphone symbol that you should be able to.
Oh, okay.
There you go.
There it is. Hello.
Good morning.
Hello. Did the dry polymer have the same efficient as the wet one, the liquid one?
The liquid one, does it have the same issue? It can.
Oh.
Yeah. Liquid polymers tend to be used at a higher dose than dry polymers, and that tends to compensate for that. But you can still have map cracking in extreme circumstances. So let's say you cast a piece of concrete and you're using a liquid curing polymer and you're using the correct amount, but it happens to be very hot. Maybe it's 35°C, maybe it's 40°C, really, really hot. And then maybe it's very dry, or maybe it's very windy. You know, you're doing a piece outside, or you've got a fan in your shop and it's blowing air and it's causing a lot of rapid evaporation of that surface. It is possible. So,
but then there again, good practices cover your concrete, and then that would not be an issue.
Correct. And you can get map cracking. It can occur after you demold it. So you could do all the proper curing practices of covering it in plastic overnight, which is all that's necessary with a curing polymer, because it starts to do its thing once it coalesces and forms that internal, you call it a curing membrane, even though it's more of a matrix. That generally happens within the first 24 hours.
I think the general the general answer though is that generally speaking, with a polymer, this is not a major issue.
Correct.
If it is an issue, then there are other causes that are probably not the polymer.
Right.
If that makes sense. So in the instance that we spoke of earlier in the podcast, where there was an issue with a polymer, with a mix that had a polymer, it was another ingredient that we have to diagnose. But generally speaking, if you have a curing polymer and our curing your curing practices are good, you're covering your concrete, you're waiting 24 hours or 12 hours or whatever it is, that's not going to be,
right.
I would think that the polymer then would not be the cause of the issue at that point.
Right. Maybe you dumped in far too much super plasticizer in your mix. Then maybe that's the cause. But it's far more likely that you're going to get map cracking in a mix that doesn't have polymer in it.
Yeah, exactly.
Because that's its job, is to hold moisture in. And if you're not using that, then what's keeping the moisture in? No. So, and that's even exacerbated even more with mixes that have low water cement ratios, because there's not as big buffer of moisture inside. And the flip side of that is, if you have a very high water cement ratio concrete, you're now making a concrete really porous, so it's very easy for the water to escape. So it's a delicate balance. That's another topic, but I'm just trying to. It's not a complex picture. It's just a picture that it's a clear picture that has a lot of little details around the edges.
So keep tuning in.
Yeah, so keep tuning in. Good question, though. Good question.
Yeah, absolutely. Well, I think we probably ought to wrap it up for today, if that's cool. And I've really enjoyed exploring this topic, and I also look forward to, hopefully some other people have questions, as time goes on and this gets posted to Facebook and the website and YouTube and all of that. So
and I think one last thing is, if you have something you want us to talk about, let us know.
Yeah, absolutely.
What's on your mind? Because
if you want, I'll give you. We can have it linked in the podcast. But if you have questions that you want us to answer, if you have topics you want us to cover, email me. My email is Caleb, CALEB .cci@lawson.design, and there's no .com or anything like that. And we can link that in the video description and the website and all of that. But shoot me an email at that email address if you have things that you want us to cover, or questions you have. Again, that's caleb.cci@lawson.design. Cool. So I think that's a good way for people to chime in, and again, join us live too. I mean, not everybody can be here at Wednesday at 8 a.m., but we love having people involved. So.
Absolutely. Well, thanks for stopping by, and we'll see you next time.
Sounds great. See you.
Bye.